Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. We meet again in this chapter for week 4. We will discuss about the waveform generators too. Okay. After we discuss about many things in the introduction of signal generators, now I'd like to show you another type of signal generator or waveform generator, I mean. So this is the attenuator. So if we looking for in this figure number 2.8 in the textbook, we know that we have attenuator here, or this is the modern sine wave generator, and we have attenuator here before the RF output. And the signal generator is used to generate the signal. So what is the function of attenuator in this block diagram? Okay, so attenuator, and the function of attenuators is to reduce the power of the input so that the ratio of the input power to the output power is a constant. And the attenuator in the second part of the generator. So we can see from this function that and we know that the signal generator is produce wave or signal or wave, and then we know that if we produce a signal, the user will put what is the magnitude and what is the frequency. So we have to guarantee that the input power or the amplitude and frequency is similar to the user inputs. So we have to put the ratio between the input power is a constant, because if we put a constant value, so there is no differences between the input and the output power. It means that the input from the user, we can guarantee that this is the output of the signal generator. So we can see that we have the two attenuator. We can put many attenuator in the signal generator based on the necessity. And if we have two attenuator like this one, we can calculate the attenuations. So the attenuation is 10 log P input per P output. This is the input, and this is the output. So the attenuator and the attenuation is decibel is 10 log Pi input power input to the output power. So in this figure, if we have two attenuator, so the total is we have to calculate of two ratio between the input to output power is like this one, 10 log Pi per PO per Pi accent here per PO accents, because we have the Pi accent and PO accent here. So we can use this mathematical solution to make a solution of this equation. So we can get that the attenuation total A dB in A1 plus A2 in decibel. So this is the circuit of the attenuator. We can use the P attenuator like this one. And if we consider the parasitic reactance in the P attenuator, so we have to use the complete circuit of the P attenuator like this one. So we include the L2, C1, L1, C3, L3, and R2 here. And this is the simple design of the attenuator. And this is the location of the attenuator in signal generators. It's located before the RF output. So the function is to reduce the power of the input, so the ratio between the input power to the output power is the constant. So this is that is the attenuator, and then the second part of this discussion is about the frequency synthesized signal generator. So we have the PLL based signal generator like this one. We have the voltage control oscillator. So this device this device is produce a signal with the control by the voltage, and then we can control the frequency and also the amplitude of the voltage control oscillator using the PLL base like this one. So this is the PLL base of the signal generator, and here I will explain the detail of each block in the PLL based signal generator. We have the voltage control oscillator here, number 1, and then it's the source of the output frequency, and it can be tuned electronically by control the voltage. And then we have the number 2 is programmable divider here. It is a logic element that divides the frequency of the VCO by an integer, so it can be entered through the microprocessor or programming switch. So we can divide the frequency from the VCO using the programmable divider, using the frequency programming here. And then we have the phase detector, number 3 here. So it provides an analog output. So that is the function of the phase angle between the two inputs. And then, so it's like a detect the phase, and then it will be controlled and loop back to the voltage control oscillator to control if the phase is enough or not, or right or wrong. So it will be give the feedback to the voltage control oscillator. And then we have the reference source here, number 4. It is a very accurate and stable frequency source, such as the quartz crystal and oscillator. So it's like a reference frequency source for the reference of the output of these devices. And then the crystal operator works at the frequency 1 to 10 megahertz. And then the last one, a loop filter here, number 5, is an analog filter that ensures the stable and noise-free operations. So this is the PLL based signal generator. We have five block diagram: voltage control oscillator, programmable divider, phase detector, reference frequency source, and a loop filter. And then this is the another type of the waveform generator. We have the sweep frequency generator. Actually, solid-state variable capacitance diode contribute toward the development of sweep frequency generator. So we can control the frequency and the amplitude of this signal generator by using the sweep generator. And then a sweep generator is applied within a generator to provide the frequency sweep. So we have this one, sweep voltage generator. And then we can control, or we can sweep the voltage output, so it's become the control voltage. And then we can control the voltage control oscillator here. So the amplitude and also the frequency of the VCO can be tuned electronically. So it's like we want to change the frequency from the one frequency to another frequency. So we can, using the sweep voltage generator in this one, or sweep voltage output, so we control the voltage control oscillator here. So the output of the voltage control oscillator will be changed. I mean that the frequency or the amplitude of the voltage control generator. And then another device is pulse and square wave generator. Is different with the sine wave generator. Here, this device is designed to build a pulse and square wave generator. So this is the block diagram of the pulse generator. And then in the pulse generator, actually we have the terminology like the duty cycle. Duty cycle is the pulse width per period. So if we have the pulse like this one, so this is the pulse, okay, like this one, and then this is the on, and this is the off, on, off, and etc. So the duty cycle is the period of on per the total of period. It's like if we have the, it's like we have the 100% of the period. So the on is maybe 30%. So the total from here to here is 100%. Okay, so the duty cycle is 30%. Okay, because the on period is 30%. So if we would like to increase the duty cycle, it means that we increase the on cycle within the total the period. So this is the one of terminology in the pulse and square wave generator. And then the last one is function generator. The function generator, we can deliver a choice of different waveform. We can control or we can produce a sine wave, triangular wave, square, and sawtooth wave. And then this equipment can usually supply output waveform at a very low frequency. And then so this instrument can deliver sine triangular wave with a frequency range from 0.01 hertz to 100 kilohertz. So this is the function generator. We have many block here. It's like this is the extension function control, and then this is the frequency control network. And then we have the upper constant current source, lower constant current source, and then it will be controlled by integer. So we have the voltage comparator multivibrator, and then we can produce whether we want to produce the pulse or we want to sawtooth wave, or we would like to produce a sine. So we can control it by using the switch S1 and S2. So we have the output here. We can choose whether we want to use the output 1 or output 2. So I think this is all of this presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh and good afternoon.